for everyone who's tuned in, I believe there are 7 of us. Okay, it's okay. So, shall we start?
Hello, Hilary.
Hi.
Hello, Eric.
Hello.
Hello, Tukman.
Hello.
Welcome everyone. So this is our 7th walkthrough. It will cover web security. If you've missed any of our previous walkthroughs, they are on the ICRAL YouTube channel. We have all the walkthroughs that we recorded during the live walkthroughs. So all of that is there. You can subscribe and you will be notified of any of the upcoming walkthroughs. For tonight's session, we will start with Hilary, who is the creator of the CTF. Then we will also have the champions of that CTF who are chasing flags. The team includes Tukman and Eric. So they'll also be solving some challenges from their perspective. I am sure they have a coordinated way in which they are going to solve these challenges. So I'm going to hand over to Hilary. And if you have any questions, you can ask them either on the YouTube channel comments or through any of our other platforms, on our WhatsApp group, on our emails, and so on and so forth, and we will follow up with them. So Hilary, you can go ahead.
Okay. So we had already coordinated with Tukman and Eric. So we decided I just introduced them and then they start and then I'll follow up after them. So Eric and Tukman wants to take the floor first.
Okay, thank you, Hilary. This is a great opportunity to share a platform with one of my mentors. While I was in NCSTP, Hilary was part of my mentoring team. I thank Hilary. Together at CK was the head of the mentoring team. And I had introduced myself in depth during the AspireCTF Winners Edition. I'll give Eric the stage so that he can introduce himself.
Hello, guys. My name is Eric Angwenyi. I wasn't in the Winners Edition, but I'm a penetration tester. Career-wise, I was in cohort 2 with Tukman and Hilary and CK were my mentors. And it's a great opportunity to be here, sharing how we did these challenges. And I hope this session will benefit someone out there. Yeah, but my hobbies, first, I love photography, video gaming. Yeah. Over to
thanks.
Hilary.
Okay, Eric, I think we'll continue. So we'll dive deep into the challenges. That is the web security challenge. CK, I think I'll share my screen. Are you seeing my screen?
Yeah, go ahead.
Okay. Yeah, so for the web security bit, we had a couple of challenges. The first one was Agent X. I'll start with that one. Reading the challenge description, we are asked, where are you from? That's the hint for this challenge. So accessing that, the challenge site, we find some text saying that a legendary attacker gained access to the server for this quest that contains some of the VPS's IPs. So if we follow that quest, it takes us to pestbin.com. Pestbin.com is more like a text editor online where people just dump the sum of their data. In this case, we have a dump of IPs. Yeah, maybe it might be helpful for the coming part of the channel. So next, we have another link. Help us get access. Help us get our flag back. Then we have a link to access. So if we follow that link, we see that it directs us to a PHP page called Access to PHP. It's still loading. Let's give it some time. Sorry. I've realized that my interceptor is on. Sorry for that. I'll just reload. Yeah, so we see that it tells us our IP. Your IP is that, sorry, invalid access. So we can tell from this that there's a mechanism from the server in which it tries to find out the IP of the client connecting to it. So based on this, we can tell that we need a way to trick the server of the IP of the client. And our best bet is that it should be one of the IPs provided from the pest. So before we go deep, we'll need a way to trick the server into providing a different IP. So like we are always told, Google is our friend. The first step I usually do if I don't know anything is to Google. So we can try and Google accessing client IP using PHP. Yeah, so if we follow the first link, we'll find it's a Stack Overflow page, which is mainly used by developers. Google usually is a great resource if you get stuck in anything. So there's a lot of details explaining how developers do it. But of interest, we hear that there's a header called HTTP X484. It's usually used by proxy servers so as to tell the server the original client of which the proxy is directing for. For those not familiar with headers are used by client and server so as to set various criteria in which you access a page. The easiest way to view headers is using your developer tools. On your browser, you can right-click, inspect element, and on the network tab, it displays request made between your client and server. So if we refresh, we'll see that when we What the browser does is make a connection to the server, and yeah, the browser tells us some of the headers that have been sent. Now these are the response headers, and we also have request headers down there. If there is anything unfamiliar to you, it's you can always Google and it will give you a lot of details. And the developer tools are quite powerful. In case you don't have any tools, they can be of great help. Other tools you can use within the developer tools is debugger. In case you're working with JavaScript inspector, so as to see the plain HTML and CSS within the website. So we need a way to change this request headers. So to do that, I'll use a tool called Bobsuit. So what Bobsuit does is intercept requests before they're sent to the server. So I've configured Bobsuit to use using an extension called Foxit Proxy. So just turn it on. So Bobsuit is a tool used by I'll call them security professionals in reviewing security details of websites. So it's a very good resource. If you're not familiar with it, I'd advise you to go check it out. But for the better part of this walkthrough, I'll be guiding you on how to go about it. So first of all, you'll need to ensure that intercept is turned on. Let me just make sure that I've closed everything first, so that we don't get unfamiliar requests. So make sure intercept is on. I'll then refresh the page. So this is what the client sends to the server. As we have learned from that page, we need the X forwarded for header. So I'll just add it to our request, X forwarded for, and I'll give it an IP. In our case, I'll give it localhost and see what happens. Just a moment. Appears that Eric, notice anything I'm not doing
Could
right?
you check the spelling you used for forwarded? I think you may have misspelled forwarded.
Okay. X forwarded. Oh,
Yeah, now it's okay.
I think it's okay. Wonderful. So as you can see, based on the response we have gotten, our IP has changed. that was, it's now pointing to whatever we give it on the header. So you can view all the requests intercepted by Babsuite in the HTTP history. For example, yeah, the one we just sent is this one, and it also has a step that it has been edited. So since we have found a way to edit how the server interprets IPs, the next step is using the first we found so as to try and brute force the correct IP address based on that base. We'll use another tool called Intruder. You just right click on the request, then you say send to Intruder. It will be highlighted in the Intruder tab. So there are a couple of settings we need to put. So for positions, remember we want to brute force the value of x forwarded for. So we'll highlight it and click add. So our brute force will only apply on that value. Next, to go on payloads. There are a couple of a set of payloads that you can use. In this case, will be limited to the simple list. There are these options apply to different attack vectors you might get, but in our case, it's just a list, and we'll need to paste it down below. Let me just go back and access it. So we copy that list, head over back to the Intruder tab, we paste it. So down below, there's a setting to URL encode characters. So you need to uncheck this option because those IPs need to land in the server unedited. If you don't do that, it will fail. Then we start the attack. Or this prompt telling you the community version of bug Intruder tends to be slow. Let's just do okay. So over time, those requests will be listed here as the brute force. You'll see there's the payload status. This is the HTTP status, 200 and to the farthest we have a length. So of keen interest is the length because we can sort by length, and you can see that for most requests they range between 213 and 219. But there's this one which is more like an outlier. It's very big. If we click on it, we have the request. If we go to the response, we see that your IP is that, which your key is Aspire, and that's how you locate the flag. So, another way you could solve this is using other brute forcing tools. For example, the one I frequently use is wfuzz. Others are GoBuster. Another one is FeroXbuster. The tools don't matter as long as you know what you want to achieve. I think any can be used at any point. Some people even use curl and it still serves the purpose. So wfuzz, it's a web application brute forcer. It has a couple of options. I had already tested the the IPs to a text file called ips.txt. So we'll use wfuzz, give it a word list of ips.txt. We'll tell it to display colors. So next, we need to tell it what to brute force. It's a header. Brute force the header, giving the header option as text coded for. And fuzz, that's where the values will be brute force. Then the next step is to input our IP, which is that. Yeah, so the functionality is close to similar. All you have to do is observe the response and look for anomalies. For example, all of them have 5 words in their response, but there's this specific one that has 7 words and 86 characters. So from there, we can just tell that that is our flag. Another approach that one would have used to solve this is using an extension from Bobsuit. So say this is a lucky approach. So in case of parameter, you just right click. But before I go to that, to install the extension, you go to extender, the B App Store, search for Paraminer. Yeah, just click on it, then install. So to use it, on any request, you'll right click. Let us refresh the request so that we can catch it. We'll just click on it and it seems that it hasn't reflected in my bulb. Let me just refresh. So you'll find that when doing security on any field, fundamentals are important. So, like in this case, you'll need to know how the web interacts and how it works. So if you find yourself having a challenge, I'd advise you to go to the basics, know how everything works. In our case, we've seen that we needed to know headers and how they work. So it's back on. Make sure intersect is on. Refresh. Eric.
Yeah. So maybe I can take it from there.
Okay.
Have you made sure it's installed Paramarina?
Yeah, I think it's already installed. Oh, it wasn't installed. Thank you. Sorry for that. So we can go back to our request. So the param-minor option is here. We can guess parameters and we select the guess everything. So this is the lucky man's approach. In case you don't know or you couldn't figure out to do. We select all defaults and the output of param-minor appears in the extensions tab. And when you click on the output, slowly by slowly, they'll be shown down here. So after some time, it will give you valid either parameters or headers that it has discovered within the application. Yeah, I think it might take some time, but yeah, those are some of the approaches that one would have solved this challenge. Yeah, I think, oh yeah, it is. So as you can see, it has also identified a valid header that we ourselves had not seen, client IP. So once more, if you don't know what it is, you just Google client IP header, and from there you'll get an explanation from Google on what it is. This Mozilla page is very useful in case you want to know a lot on HTTP headers. For example, this is a detailed explanation of the it's forwarded for. And it's more or less similar to the client IP header. You can go through it to better be understanding on it. That's it for me. I'll hand it over to Eric to take us to the next one.
Thank you, Tukman. I will share my screen. So the next challenge, I'll be handling cookie jar. And the description is, the admin has your flag. So first of all, the header has a hint that is a cookie, and cookie is pieces of information saved by browsers, which can be used to track user activities while surfing the web. It can also be used to enhance user experience while accessing different websites. And you might find also in some systems where it is used for authentication. So you will find that it saves sessions for a specific user. So accessing this site, it brings us to this page where it shows, it displays hello user. So we are a user. You need to be an admin to access this page. So with the hint that we had in mind, we can try checking out whether there is this website has stored some cookies and whether we can edit them and find something interesting. So there are two ways of doing this. You can right click, then inspect element. On the storage tab, we see cookies. And there is one cookie where it has a role and a value of user. So we are told we have another user, which is, we are told, use the admin has your flag. So we can try to change this value from user to admin. Then reload the page, you see if we can access this page, the admin page. Yeah, and we can see that it displays for us the flag. So there are different ways of doing this. Another way is there is an extension, Mozilla extension called Cookie Editor, where you can access your cookie from here. So reloading the page, then editing this cookie from user to admin and saving it. Reloading the page, we see the same flag. So those are the two ways of doing it. Let me hand over to Tukman for the next challenge. Tukman?
Oh yeah, thanks, Eric. So in case of any questions, we can plug them in. So in case anyone is monitoring the YouTube chat, you can also tell us in case there are any questions. Okay. So the next challenge will go to executor. So the hint provided didn't give much of what one was supposed to do. Just say that identify the vulnerability and get the flag. This was one challenge that we didn't manage to solve during that time, and I'll possibly show you why that was so. So accessing the challenge site, all we find is a blank page. If we inspect, there's nothing much that is revealed. So another another way to assess a site is using curl. A curl is a command line utility that can mimic a browser. It's just that it doesn't render the output. So going through curl, we see that there's not much. The server just responds with free text. So the first thing to do will be to fuzz for parameters. By fuzzing, I mean brute forcing. But that approach didn't quite work using wfuzz. We did spend ages brute forcing for parameters, but it didn't work. We also tried brute forcing for directories, but we still will not be able to find anything. So after doing a postmortem, we did discover there's a tool called Agent, which is more or less a tool used to brute force. You can view the manual pages of Agent to find out. How to use it. So all you have to do is declare the method. If you have a custom word list, you can give it the word list and also the URL. So in our case, we'll say the method is get. And, we'll use its default word list and give it a URL and see what it might get. So it's good that anytime you use a tool, you understand what it does. And if one way of knowing how a tool works is redirecting it through Bob. And from there, you can intercept the request and know what is being sent. And you get that Agent has a way in which you can declare the proxy port. And once you declare that, so apart from this, also another tool that you can use to fuzz is the box with param miner. You can use it to fuzz for parameters, and the intruder can be used to fuzz for directories. By fuzzing, like I said, it means to brute force given a word list. So just for comparison, I'll once more send a request to Bob. If I can get it, yeah, it is. Send it to Bob. Refresh page. Now once it catches it, make sure intercept is on. So once more we can guess for get parameters. using param-minor. So it has its default word list, which I think is quite handy and contains most of the common parameter names. But in case you want to use your own custom, you can always include it in this part. So for this case, we use the custom one. And you can always view its output in the extensions tab. So as you can see, it has started the person. After some time, we'll come and view the results. So back to Ajin, we see that it has discovered a parameter called IP, and the factor it used is HTTP and headers. So we can test it out in our browser and add the parameter. So forget adding parameter, you'll more often hear of query strings. Query strings are a way to add parameters to a GET request. And to do it is that you start with a question mark, the variable equals to its value. So in our case, I can say IP equals to 1. If I do that, you'll realize it will load for a while. And yeah, we see that it's being statistics for what we input here, with that is 1. So let's try it with a valid IP. You can do localhost. And as you can see, so what we discover is that the server takes the value we passed to it and execute the command ping onto it and displays the result back to us. So how can we leverage this so as to gain access to the server? So there's a technique called command injection, where you inject commands on user input given to the server. That is, if the user does not have any validation. So there are different ways to achieve command injection. One common way is chaining commands. Those familiar to Linux, chaining commands is possible through semicolon, then putting another command next to it. For example, this is one technique that mostly works, but in our case, we find that it doesn't work. So there are different ways. For example, this was the first one. Another one is using the pipe command. Yeah, and from this, we are able to see that we were able to achieve command injection since the command to list directories was successful. So the next step will be to view contents of the text file that we just viewed. And in Linux, there are a couple of ways to do that. The most common one is cat. The cat command lists contents of a directory, the contents of a file. So if we do cat, and test that file. For some reason, it doesn't work. So what if we use a wildcard? So as to say, display any file that ends with .txt. So if we do that, still nothing happens. So it seems that maybe something is up. So let's do an experiment. Type a command. What it does, it displays whatever string you give it. So for example, just type something random, just if cut works. And as you can see, there's a sort of a filtering technique by the server, which more or less filters the word cut out of the user supplied input. So we'll need to use an evasion technique so as to view the file contents of the text file we just saw. So there are a couple of evasion techniques of which I encourage you to go through. If I can access. There's one by sectors. It's very handy. There's a lot of evasion techniques well explained. You can just search for web application firewall evasion techniques, and they're well explained in detail. And most of them utilize wildcards. Wildcards are I don't know how to explain it well, but yeah. So there are a couple of them. In our case, one we can use is the apostrophe. So for example, in Linux, txt. So if we do cut, it works. So one thing is so what I wanted to explain seems not to work at the moment, but this is one of the evasion techniques so that adding that as the PHP code tries to find the word cut, it will not find it. Another technique would be doing the hard cut, then in between add the value cut, so that even if the server removes the hard cut, will still remain with the value command. So if we do that, as you can see, it still goes through. We can try and retrieve the source code. So this is the source code. Let's just try and go through it. Yeah, so we can see that this is the point where the server obtained the value of our IP. From there, it performs a trim so that it removes any white space. So we can see that there are a couple of things that are filtered out in between the tail and the head, which are mostly some of the commands used to display contents of a file. I think that's it from me, and I'll invite Eric to take us through the next step. Any questions?
Okay. Any questions? If there's no question, we can continue. Okay, so I'll be handling filer. So from the description of filer 1, find the vulnerability, look around, and you will find the flag. Can you access our passwords? So trying to access the site. We see there is an error. I can't see a file error. So meaning there is something that is either running on the background. And the steps that I took, first, I fuzzed for directories. So I used Buster to do fuzzing for directories. However, there was nothing of interest from there. The next thing, I checked the HTML code, view page source. Still, there was nothing. So with how these challenges are going, the next thing I did was checking for query parameters. So I will intercept this. I'll intercept this request using BAP. Yeah, so I'll use param-miner to fuzz for parameters. So guess params, then guess parameters. So as you can see, still it uses this. You can also change it to, maybe after the results and there's no successful parameter, you can change it. So we'll still use this one. So from the results, extender, not extender, yeah, extender, then output. It will fuzz for the parameters. It might take some time. So we can try other things out. Let's say look for robot.txt. As we wait for it to finish. There's nothing. Okay, it has finished. So we can see it has found one query parameter, which is file. So we'll use this. And how you write it is with the question mark, then file. Then from here, there are so many techniques to use. For example, we can do command injection. We can try that. We see if it's possible. And since this is a Linux machine, we can start with that. We see nothing. We can do as my colleague Tukmen did. We see nothing. So it seems that there's no command injection in this. Another thing you can do is remote code execution, where remote file inclusion, where you're trying to include your file from the attacker machine and trying to either run it on the server or upload it on the server. So we can try with the ips.txt. So we can try by setting up a PHP server. So then we check our public facing IP. We see if anything hits our server. However, this is not possible because we are using a public IP, and this machine might not get directly hit from it because you're using a shared IP, Zuku IP. So maybe Zuku IP or Safaricom IP. Anyway, so that I tried, didn't work. So the next thing we can try is trying to access local files. That is local file inclusion technique. We can try by first accessing the common accessed files. Maybe you can try etc passwords. And from our hint, it's saying find the can you access our passwords? So what instantly hit me is, can we access etc shadow? Okay, let's try accessing that. But most cases that it's usually we don't have permission to access it. So let's just try. We can't. Let's try that way. Still we can't. Most probably is because you don't have permission to access that file. So let's try etc passwd, which usually has our users, the server users. So let's try that. Yeah. So as you can see, we are able to access and thereby solving the first challenge because we have the flag there. So for filer 2, the next challenge, almost the same. Can you access our passwords? So let's get the website URL and try accessing it. Let's try the same parameter and try accessing passwd. Hacking detected. So we can see there is a kind of mechanism which detects that you're trying to access a file from the server. So there are techniques that you can use to evade, and one of them is this site, which is very, very useful. It has so many techniques. But of interest was this. Here we see that it uses PHP filters. Then it uses classic cryptography methods like base64 and ROT13 to first access and encrypt the files and encrypt the file that you are trying to access. So we can use this. We see if it's possible to evade that maybe filter mechanism that has been put in place. Okay, so we can try this one. And since it uses PHP and our site also uses, hopefully it will work. And our resource is etc passwd. Still not working. Okay, let's use other techniques. See, it seems that base64 encryption is detected, and let's use another one. Let's try ROT13. ROT13 is a classical encryption which shifts characters 13 times. Let's say A, the character A, it's shifted 13 times. Yeah. So let's try that. Yeah, and we have managed to access it, to access a password file. Something else is that you can find scenarios where also this might not work. So another thing you can do is probably changing the letters to maybe capital, you switch it to small. You play around with it. You know, in real life, it might not, one technique might not work. So you try different techniques. It still works. So changing the letters is it's another technique that you can use. Another technique you can use is changing this to hex. So let's convert ASCII to hex. Oh, sorry. This is hex to ASCII. Okay. Hex to ASCII. No, ASCII to hex. Sorry. Yeah, so using this, I'm not sure if it will work for this scenario, but we can still try. For this scenario, it didn't work, but that's another way of doing it. Yeah, so we got our flag. We got our flag from the file, and yeah, that's how I solved it using PHP filters with ROT32 encryption. This is a very useful website that I usually use. You can, when you find your time, you can come and check. Yeah, so on to the next challenge, method man.
Eric,
Yeah.
the flag you found,
Yeah.
it doesn't read Aspire.
Sorry. Oh, sorry. Okay. Yeah. So from here, from here, this it's ROT13 encoded. So we need to revert it back to our ASCII, to our values, to the true values, since this is encoded. And I said that it's shifted 13 times. 13 times. So we can use online tool for decoding ROT13. Okay. Yeah. So as you can see, it has been decoded, and we see our flag. Yeah. So on to the next challenge. Method man. The description is the admin is particularly fond of numbers from 0 to below fond of numbers below 200. Find what he has hidden. So first we get the URL. Let's close this. And see the site. And we find the same thing from the description. And what came in mind first is, okay, there is a query parameter somewhere, and it's getting, let's say for example, user is equals 1. So that's what I thought, like a particular number from either from 1 to 200, so a particular number. So with this in mind, I intercepted the request. Let me restart this. With Babsuit, then used paraminer, the extension in Babsuit, to guess which parameter is that we'll be using. So I'll just leave it as it is by default. then let it run. And results will find them from here. Yeah, so it might take some time. So to save time, I'll just use the correct parameter. So the parameter after this runs, and we'll come to see it after it has finished, is code, the parameter. So something like this, code. So we know that first the parameter is code, and we know it will accept a number from 1 to 200. For example, 2. I'm not saying it's that. For example, 2. Yeah. So what we'll do here is next thing is fuzz these numbers so as to get the correct number that was used by the admin. Yeah, so this has finished, and we see the correct parameter is code. So from here, we know that our query parameter is file, and it accepts a certain value. So we'll send this to Intruder, which will do the brute forcing of the values for us. Yeah, so from the payloads, instead of simple list, we'll use one with numbers, and we'll put 1, then to 200. And for the steps, we'll put 1, so that 1, 2, 3, 4, and yeah. So
just to interrupt you a bit,
yep.
the parameter was code.
Yeah.
Not file. Yeah.
Oh, sorry. Yeah. So we'll start the attack, and we'll wait and see. We'll take note of the length, because as you can see, the status is 200. All of them are 200. So we'll take note of the length. So I already ran that, and so we can check. Let's take note on the length. You see, so we can see first 267, the length, and it's 46. We can also see 79. So let's try this 79. So from Babsuit, we put input 79 and see what happens. Oh, sorry. Let's do this again. Let's intercept it. So let me close these other pages. So, okay, we found our value to be 79. So let's input 79 and run. Yeah. So we have found the flag, and the flag is as displayed. Yeah, so I'll hand over to Tukmen for the next challenge.
Thank you, Eric. I think Hillary will take over with this way. Hillary?
Okay, thank you guys. That was really interesting. It's really good to see how you guys solved it, how you guys solved the challenges, and that was really amazing. Big up to you guys. Thanks a lot. You've really saved on time. You guys did like half of the work, and I'm really grateful. And keep up the good work. Great team.
Thank you.
So I'll share my screen. Just to confirm, can everybody see my screen?
Yes, you can see.
Okay, so you guys have looked at Agent X. So I'll just go to this code master bit. So we have our so those are something that happened during this setup on the VPS I was currently using. But since I replicated the same stuff on my laptop, I think I'll just use that. So just use my local host, Aspire, and we have code master. So this was the challenge. How good can you identify vulnerable code? Prove it by getting the flag. So put this single hint right here so that we can be able to see the source code and just get a glimpse of what's happening. So we have a PHP source code here. So we have the flag, which is hidden right now. The insert get, so this just means we have a get parameter, which is key. And we have the irreg, which is used to find a string within a certain parameter. So in this case, we have the get parameter we had right here. And instead of a string, we have a regex. So this basically says we're looking for alphanumerical characters, or if I may call it, we are looking for alphanumerical characters. So this just symbolizes the beginning and this the end. So within that whole string, there's some alphanumerical characters, and it just confines our string to this. So if it's false, your password must be alphanumeric, and then we have another match. So we get the key has to be greater than wait, this is a check for the string length. So we're checking if it's greater than 9, and if it's less than 9, if it's greater than this. So, and then we have the string position. This just says we're also looking for this string in this parameter of ours we have here. So if everything matches up, we're supposed to print out the flag for us. So what we did here is, I hope I've zoomed in enough. I think I'll just use Chrome since the Chrome tab is usually a bit bigger. Yeah, so I'll just copy this and do this right here. we have the same thing. So, okay, from this source, we know there's a key parameter that's expecting something. And let's say we give it something like whatever, something like this, we get an invalid key. And if we actually look at the code, there's some stuff we need to obey. And this was testing your ability to Google. I know it's reading code and stuff. We already know what we're looking for, but we need to Google some stuff. So we're looking for a character that's greater than 9. And it's also greater than this character we have here, this number we have here. So the best way to do this was, I Googled around as well. And I was expecting you guys to also Google around. So if you do some really heavy Googling, there's a bypass for this, which is widely known as the scientific notation. So this is how it works. If I say 1, then I say this E, and I say something like 9, this will equate to a number like, so this is zeros. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will equate to 9 zeros. So by me doing this, I literally have typed this, and this is what the code will understand when I do this. So this will obey that rule. It's greater than 9. I mean, it's less than 9, not greater than 9. And it's also greater than this number right here. So if I do this, I'm supposed to get the same thing. 1, and then I do E, and then I do something like 9. I can even put 8. It doesn't really have to be, since these digits are 1, 2, 3, 4, 5, 6, 7, 8. So the number just has to be anything more than this. So this will obey it very well. So something like I put 9 here. And if we actually look down here, we have another match. So it's also expecting this. So I can literally just copy this and actually paste it here. And this will not work for specific reasons. It must be alphanumeric, which it is, but we're missing something. So as it is right now, we have to truncate this. So this is a bypass I learned. It's called the notation bypass. It works for arrays and different strings. So for the bypass, I tried a couple of stuff. So they say we have to concatenate this, like to truncate, not to concatenate. So I tried this, did not work. It's not alphanumerical in any way. So what I ended up doing was using the null byte character to truncate whatever we have here. And this should end up giving it a flag. So it was more of Googling around for a bypass on how to truncate different very large characters. And this is usually a classic one. And the rest of the bit was just understanding the code and knowing what different, like the E grep does, like the S pros there. Let me just go back. So we already have the flag basically, but the whole point was understanding what the source code does, knowing what error does, understanding what this does. We're looking for get parameter, which is the key, and this bit as well, string length, and knowing that the string pause is looking for another character or whatever we're defining here that will be present in this key element. So the rest of those are just normal checks. So that was a simple way. So that basically involved a lot of Googling. So for the other one was, so we looked at the code master executor 1. Did you guys do executor 2? Don't think I saw you guys doing executor 2.
The same bypass worked for both of them.
Okay,
but maybe you can tackle how we were supposed to do it.
Okay, so let me just copy the URL for the executor too. Let me just use this here. So the parameter was that executor 1, executor 2. So the get parameter was IP. Oh yeah, just forgot. So the IP was so I want to send one. So this not supposed to see that ping thingy. Let me try the same one. Let me try the same here.
IP equals instead of space.
Ah, yeah. No, what's up. Equals. Oh, yeah. Confusion. So we have that, and using the same methodology you guys used, we can even see if we do something like ls, we get the file. Okay, forgot to delete this, but just explain the whole thing, how I did it. So since we can't even access the file directly, so I put in this measure to make sure we cannot access the file directly. If you try to access it, it's supposed to give you a forbidden error. And so cat did not work. If we did anything, it wasn't supposed to work. So this just required a bit of creativity. I know there are like 1,000 ways different people are going to solve this, but the way I would have done it was, or the way I designed it was using different things like say, try to look for something like zip, if zip is installed. So this is general error. If you're doing this from the browser and you get this, just know probably zip is installed and there's a zip file somewhere here, of which there is. But I was trying to zip. Let me just do this. So since we cannot access this and we want the contents of this file, we can try and zip it. So the general syntax of zipping is and then the file we want to name it. So it's just say aspire.zip, and then we give it whatever we want to be archived in the zip. So we have a permission denied. I think there is an error on the server as of the time I was configuring it a few minutes ago. But what it should have done, if I named this to zip as I did earlier, we're supposed to compress it into a zip.zip archive, which we already have. So yeah, this was the file. So if we did this, we're supposed to get this file. Supposed to create this file on the server, and we're supposed to be able to download it. Yeah, so there's just a small issue I did, but initially when the challenge was up, this was very much possible. So just look at the zip file and the file that was inside here, and we just open it and we have our flag. So yeah, that was one way of doing it. So that's that. So we have the executor to that was how I solved it. The second one was the good doctor, which I believe this was kind of easy. So I had a few challenges setting these things up. That's why I'm using my local host. So I tried setting it up, setting up the PHP and stuff, but run into some errors. So I still have the same instance in my local host. So as long as we know the process and the procedure of using it, I think we're good to go. Let me just close this. So this was the challenge. I named it the Good Doctor, and I think it was pretty straightforward to actually think this was an SQL injection challenge. Yeah, so the SQL injection, the Good Doctor, goodies. Yeah, so we can try something so simple. Get the error. We're not authorized to do this. So classic SQL injection, we usually have some payloads that are supposed to enable you to do authentication, which that was the easiest way to do this. And we can formulate a very simple payload to do this, which is something like so let me do this. And then we'll do a limit where we only want for in SQL, MySQL is just defines what you're limiting the query output to. So if I limit to 2, we're going to have 2 outputs, but we want 1, since in most cases when you're doing SQL injection and you're limiting it to 1, the first result is usually the admin of the whole SQL DB. So we can put in a comment to ignore everything after this, and that payload is supposed to be sufficient if I'm not wrong. Yeah, so that payload is supposed to log us in, and from the look of things, you can already see that. Another way to do this, another way to do this would be classic SQL map, which was also supposed to work. So this is my local host instance, but just to give you a good overview of how things are supposed to go. I use BAP a lot, so that was my go-to, although you don't necessarily need to use BAP. The reason I'm using BAP is because there's a post request that we need, and we need to be able to capture that post request, since our get request is just straightforward. Yeah, so to do that, we have this, do not mind the licensing. So we'll just put in any dummy data, A, put in A, and then I'll set this proxy on the folder, and wait, yeah, the proxy. So I'll log in, and then I'll put the. So this is the post request we're looking for. Aspire, Good Doctor. So first thing you can do is save this to a file. You can copy this to a file. Maybe in the desktop, save it as whatever. I don't know, tester.txt. And then if you have Backsuit, meaning if you have SQL map installed, you can use that. Here's our test. Oh, yeah. Yeah, we have our test.txt. So if you have a SQL map, you just use something map -r, which means file, and then just paste in our that. Then you can just adjust the levels if you want to. You can adjust the list to maybe the highest number. Since I already know the database, the DBMS. DBMS is SQL, so set it up, and you can do DBS. this was supposed to do its thing and give you the vulnerable parameter is supposed to be the user. So this will take a while, but yeah, this is the whole process. So if you do this, you're supposed to, you can even see it appears to be in MySQL. This, you want to proceed. You want to skip? Yes, you want to skip. You want to include all tests? No. You want to follow? No. Another thing will be using the batch flag. It will autofill everything for you. Since so I'm putting in so much yeses and nos. So this will do its thing and autofill everything for you. So if you go ahead with this, why did the batch not work? It's supposed to have worked. Yeah, so long story short, this how it's supposed to go using SQL map. This is the exact syntax of using the SQL map minus array from file, adjust the levels, the list. We want to see the databases and this specifies the database management system. Yeah, so supposed to work and if you give it enough time. And I think because of the time we have, we're actually on track, but I think this is sufficient enough. So if we leave it, it's supposed to dump all the databases we have and it's supposed to save them. Yeah, so this was a simple challenge. Maybe we can turn this off and go to the next challenge. So word 1. So this next challenge was a bit unorthodox because it's not a conventional CTF challenge. Personally, I've never encountered a challenge like this. So from what we have for words, it just goes ahead to teach a lesson on how words are important. Words used in a website are important. No words are just usually just written anyhowly. They're there for a reason. And let me close this dashboard. Yeah, so the first step to this was using a directory brute forcer or fuzzing if you want. So we're looking for directories, we're looking for files. And that was the first step. So we have this. And my go-to tool of choice is usually dir search -u, and then I'll give it that, and then I'll give it the let me just specify maybe the extensions, we want everything. And then we're looking for, let me specify a path to the word list. Now word list, we have configs. So this is supposed to brute force this directory and find different directories, subdirectories, and files that are under this. So if we start this, it's supposed to do its thing. And I know people have really long word lists, so I curated this to make it a bit easier for time purposes. So we know there's a file that has returned a 200 and some status code over here, the status code and some the length. So the file is .env.bak. So this is supposed to teach guys to know that developers usually back up stuff and they're not usually in the conventional ways. Like this is a env, which will probably be found in a Laravel application. And the BAK usually just the extension for the general backing up. It's a general extension for backups. They usually name it like that. So if I did this, it's supposed to start downloading this and we'll open with gedit or and we can be able to see the flag. So our flag was Aspire, whatever, the long string of it. So that was the first part of what. That was our one challenge. The next one was basically understanding how, let me just do it. I'll just copy this. And then I'll use a tool, Seal, which I'm guessing everyone knows about. So Seal is a tool that usually grabs the different words from a website. So if I do Seal and execute this, there are different arguments you might use, but this is sufficient enough. Yeah, can't reach this as a normal user. So if I do this, I'm supposed to get all the words that were used in this on this website. So all these are words. Let me create a new tab and let me just nano. I use nano click every time. Write the words. .txt. And then I'll paste them there. So one thing I've learned from different engagements is whenever these words are used somewhere, they're usually used in a different type of way. If I may explain it, like if a word like maybe I usually like using Safaricom as an example. Maybe say they have something like Fafanuka, most likely they'll have something like Fafanuka.zip somewhere. So that's where I learned this from, and it's been a bit fruitful. So what I usually do, and maybe it's something different people might learn, is if I do something like, so these are all the words we have. So I might do this, maybe I'll go and put them in a word list.txt, append everything there. And then I'll also use something like sed. Fat fingers. I'll use sed, and I'll go at the end of every line. I'll append something like .zip. Again, fat fingers. So this just appends this string at the end of every word. So a good thing to do will be put everything in a the word list file that you have. Oh yeah, I mistyped it, but same thing. Put them there. I usually go through all the compression formats we have. We have .tar.gz. Let me just use those two for now. And we have that. So we're supposed to do the fuzzing using the words we've already found so far. And we're going to use this word list. Same command we had before, but we're going to use a different word list. So here it is. And the word list we're going to use is r.this. Let's see what else we'll find. Yeah, so apparently we found, using the words we've seen on the site, we have a couple of different directories. So we have this directory, which we can open, which brings us to another lead. And we have this as well, which I can open. So let's start with this one. Now that you're here, you should know that our forensics team found an attack on the system. We don't know what they took, but log shows he he compressed it before, he compressed it here first before transferring it to his server via SCP. Help them find the file. If you can't, we shall send our lead investigators to get the job done. So we already know they compressed something. That is why I was insisting on this, appending this .zips, .tars, .rars, .7z. You can do anything, just be creative with them and just know how developers usually think. So we have that. So I'm going to use this new link with the same word list we had. We know they compressed the file, and this is the directory we have that's a bit interesting for us. So let's run the dir search here. So we have a status 200, and there's a file called compartmentalize.tar.gz. Let me load this. Downloaded. So if we open the file, we can see there's a flag here, which is okay. So you're here, good wording skills. Here, first before you proceed, so here's the flag. So we've kind of solved that. But there's also another directory found, which is this. So far we've already solved 2 flags. Our forensics team also discovered that the attacker tried to edit this page just before it was made. So there's a page here. If we do our index.html, yeah, so clearly it's an index.html file. And we can, from the evidence we have, is the attacker tried to edit this page because he was trying to add something. So this was trying to just show if someone is trying to edit something, if on a production server or any server, if a developer is trying to edit something, most likely, most of the cases they are using Vim or another text editor, but mostly it's Vim. And Vim has this misconfiguration that usually comes by default unless you disable that file. It's creating a swap file, which is supposed to be .index.html.swp. So that's probably in your word list, but usually not such the case where it's not usually not in many word lists, but custom word list is supposed to have something. So if someone edited something and maybe on Vim and they forgot to disable that function, it's most likely going to be saved as with a dot and then an SWP at the end. So if I load this, it still looks the same, but if we come to the source page, you can be able to see something they commented out on this SWP file, which was some configurations that and we have the flag right here. So yeah, so the lesson for this challenge was knowing how word lists work and knowing how to generate word lists from different words used in a website, usually keywords, very keywords. Yeah, I think that's that. Where are the challenges? Yeah, so that was word 1, word 2, and word 3 respectively. So all the 3 flags belonged to the different sets of words. So the final challenge was word the street. This was a WordPress kind of thing. I did not have a very good creative naming mechanism, but this is what I came up with. So we have word on the street. So yeah, so this was the other thing. So I lost track of time and I was not able to set up everything correctly. So I'm still going to use my local instance. It's a really big thing. It's like 40 MB of WordPress. So common enumeration, you need to know what the site runs on. Don't really have to look at any tool. You can just inspect element, or you can just use these. These are big. And need to look for WP something. There are different comments here. You can WordPress, WP content, all these things can just tell you this is a WordPress site without even having to look at any tool. Another tool, if you really have to look at the tool, is Wapalizer, which I don't know if I have. Yeah, it is. Oh yeah, okay. On the main site itself. So Wapalizer, if you have a WordPress, you have this version, whatever, fishing admin, and different kind of things. So I'll just copy this URL. So the first thing, if you have a WordPress site and you need to dig deep into it, the first thing would be to enumerate different users, different plugins, different things, and you can actually try that on some free time. But the best thing would be to use WP scan. You can just use WP scan, and then it's usually nice and then this plugin, it's called plugin detection. We'll just set this to next, since we're using both active and passive methods for gathering the plugins. And let me just copy something here very fast. This will just ignore any redirect. I had it pasted somewhere so that I don't type it again. It's plugins. It's not plugin. So on the first instance, it's supposed to update the database. I've already updated it. We have that version right there. So it's going to do some enumeration to try and discover the plugins that we have. This is not supposed to take that much time since we're running it on the local host. But for the sake of time, it's kind of fast. But either way, for the sake of time, once this runs, we're going to look at the results, but let me just go right into it. So the vulnerable plugin was Site Editor, and it was version 1.1.1. So this is a generally known plugin in the WordPress community. So it's known for this classic LFI local file inclusion exploit. That's the CPE ID right there. So let's just pop into this. So here we have it, the site editor. You can see the description, the details. So there's an Ajax parameter allows remote attackers to retrieve arbitrary files by the Ajax path parameter. This is the path. So we have this path and we have this parameter that's vulnerable. And since we have the same installation of the same plugin, the same version, you can take a look at this. So I'll just copy it and I'll paste it here. Let me just start with the site first. Just the end, I'll paste that here. This on the proof of concept. So it's the host, WP content. This is the POC. So this is what it is. So let's grab everything from here to here. Yeah. So apparently the POC works okay. So we're supposed to be able to read different files, but for the sake of this CTF, since it's just a measure to know your vulnerabilities and how to find them, we just use the etc file, which is this. And if we look at it properly, we can see here's the flag that we're supposed to use. Yeah. Oh yeah. So the WP scan has finished. We have there are no backups found. But if you read through all this, you're supposed to read through it. It may not literally give you what's vulnerable. That's upon you to find out. So if you look through this, you can see a lot of stuff. But here's the site editor. So in this case, you're supposed to go through all the plugins and research for different exploits that have been available. If any plugin is vulnerable to anything. So this was the plugin I suppose I used in the CTF site editor, and the version we have right now it's 1.1. So far, that's the latest plugin version. I don't think they fixed it. Yeah, and I think that brings us to an end. Any questions? I believe that's everything, and I believe we covered everything.
Thank you, Hilary. I think due to the advancement of time, we will have any follow-up questions directed to the Aspire team, then we can follow up with any of the presenters today so that we have a conclusion to a session. If you missed any section or any part of the recording, it's on our YouTube channel, so you can view it at any point. You can refer to it. You can practice and see the different ways of solving the challenges. If you discover new ways, even better. As they demonstrated, there are several ways you can solve these challenges. You don't have to follow one static method. And sometimes one method works, another one doesn't work. We will continue having these walkthroughs. I think we have a few more weeks remaining before we complete all the walkthroughs. And then after that, we may have some new challenges coming up. As a reminder, we will be having a CTF challenge in collaboration with one of the community groups next month. So look out for that. Next month is the Cybersecurity Awareness Month. October is usually the Cybersecurity Awareness Month. So we may also be doing some other events around that month. So also be on the lookout on our social media channels and all other communication channels. For here, we'll end this today. Thank you to the Chasing Flags team. Thank you to Hilary, the creator of the challenges. Thank you to the coordinators, the Aspire team. And I hope you had a good time. See you for the next walkthrough in about a week's time.